Now let's move to one of the most important ideas in modern AI, embeddings. Every word or token in the vocabulary does not stay as plain text. Instead, each token goes through an embedding process, which converts it into numbers that a machine can actually understand. An embedding is simply a multidimensional vector. That means a long list of numbers. You can think of this like giving every word a numerical fingerprint. In the image, you can see examples like man, woman, king, and queen. Each of these words is represented as a row of numbers. Now, look at the labels above those numbers. Things like living being, human, gender, royalty, verb, plural. These are called features. A feature is just one aspect of meaning. Each number in the vector tells us how strongly a word relates to that feature. For example, the word king scores high on human and royalty, while woman scores high on human and gender. Important note here, this is only a simplified simulation. Real models don't use human-readable labels like royalty or gender. They use abstract dimensions that the model learns on its own. But the idea remains the same. All these numbers together form a point in a high-dimensional space. On the right side of the image, you can see this idea visualized. Words like man, woman, king, and queen appear as dots in space, and the distance between them represents meaning. Words with similar meanings appear closer together. Now, here's where it gets really interesting. Because these are numbers, we can do math on meaning. That's why this famous example works. King minus man plus woman equals queen. This doesn't mean the model understands gender or royalty like humans do. It means the mathematical relationships between vectors align in a meaningful way. Now let's connect this to large language models. The slide mentions that GPT-3 uses embeddings with 12,288 dimensions. That means every single word or token is represented using 12,288 numbers. Each of those numbers captures a tiny piece of meaning. Together, they form a very rich and detailed representation of language. These embeddings are usually stored in vector databases, which allow fast searching based on similarity, like finding words, sentences, or documents that are semantically close to each other. So when you ask ChatGPT a question, it's not just matching words, it's comparing meaning in this high-dimensional space. That's why it can understand context, synonyms, and even analogies. In simple terms, words become numbers, numbers capture meaning, meaning becomes math, and that math is what powers modern AI.